Hello, and welcome to yet another fan request on Answer Everywhere. I've got up here my list of fan requests so far. We have about 53 of them. I went ahead and did my ordinary procedure, which is I grabbed the latest Taylor Swift tweet and I grabbed the Bitcoin price and I plugged them into my Python script here to generate some entropy. And this is what came out on the right. And I went ahead and popped that into the spreadsheet. And now we have a top 10. Hello, and welcome to yet another fan request on Answer Everywhere. I've got up here my list of fan requests so far. We have about 53 of them. I went ahead and did my ordinary procedure, which is I grabbed the latest Taylor Swift tweet and I grabbed the Bitcoin price and I plugged them into my Python script here to generate some entropy. And this is what came out on the right. And I went ahead and popped that into the spreadsheet. And now we have a top 10. Whoops. This is the top 10 here. So our options are GNOME Shell, hping3, Core Utils, Ogre 3D, C Groups, Wicked Engine, Bitcoin, TCC, Redis, or ZSH. Let's go ahead and roll a d20. 2. 2 is hping3. Now, I don't really know what hping3 is, other than it's a utility for, I think, crafting like custom packets. So like a fancier ping. hping3 is a network tool able to send custom ICMP UDP TCP packets and to display target replies like ping does with ICMP replies. It handles fragmentation and arbitrary packet body and size and can be used to transfer files under supported protocols. Okay, and I see that this is a Kali Linux page, so I guess this is used by the same sorts of people who are into Kali Linux. Let's go to their GitHub. I'll clone their repo, although I suspect that with several of these networking tools so far, they've been pretty small repos. So I'm guessing that there may not be a ton of stuff here, and it may not be necessary to jump into Emacs. But we'll clone it anyway. See if I still have my tags command. No? Yep. All right. And let's see what we have. So we've got the standard thing that we've seen in networking utilities, and especially for slightly older repos, which is that all the C files inhabit the root directory. Although we have a lib and an img, we have RFCs. I'm wondering if RFCs are just imports of these are not like the homes of the RFCs, right? I guess this is possibly just for reference, right? And what makes this hping3? Let's verify that we have the right release. No releases. 11 years ago. I'm doing just a search for hping3. I'm not sure if I did that. Yeah, that's what I did. Advanced version of the ping command. All right, well, I'm guessing that this is hping3. Let's see if it mentions it anywhere in this repo. Okay, so I believe this is probably hping3. Let me see if it says it anything in this. Yep, hping3. Awesome. So let's dive in. And I'm going to update the name of this stream. Far out. All right. Okay, so let's dive in. What do we expect to see? Well, we've looked at a few things now that construct network packets. And um, I guess I feel like from from my perspective, a whole lot. Um, there's not a whole lot to it. Usually, you have to know the RFCs well. You have to have a sense of performance, and so often they're written in C. But modulo understanding what the RFCs say, there's usually not a lot of like cleverness or architectural choices that are going to show up in the code. And so I'm expecting it to be mostly pretty straightforward. Let me pull up when it was originally written again. 2005. That's not too old. Um, but it may be, it may the code may look a little bit not antiquated, but old school. All right, here we are in lib, and in lib we have reg test, which is good. I'm guessing this is regression test. We have a README that tells us that in this directory are scripts in this directory are all under the GPL license. Okay, what is HT control or HTickle? Fire TK. Are these tickle script? So show TCP sequence numbers read from the specified interface's traffic graphically. So let's find out what these are. Compiled HTML. Can't be right. Don't believe it. Tickle. HTTP CLD is a very small HTTP parser with an embedded tickle interpreter. Hmm. Add detection support of tickle scripts. Yeah, I'm gonna just assume these are tickle scripts. Does GitHub doesn't want to tell me about tickle. Probably a conspiracy against tickle users. Okay, so we're going to ignore the tickle and jump to the C. And we have everything just hanging out here. So let's try to get a sense of what might be important from the names. So anti-get opt. I don't know what an anti-get opt is. It's like the opposite of getting an opt. We have add buffer, maybe address buffer. Ours glue. I'm not sure what ours is. Binding might be important. Checksum, configure. This is, I guess, probably just configure for make. Data filler, data handler, display IP options, fixed types. I'm kind of curious what fixed types is up to. Gen tables. I guess this is for printing out reports. Let's see if hping3 has reports that we can see examples of. You at least get like, I don't know if you would call that a table. It's just printing a bunch of lines. See if they have tables. Yeah, this seems to be like a table. So maybe they are tables. We have compare hex, I guess support for maybe binary to hex. hping2 header. Some string stuff, interface, possibly network interface. Listen, main. I guess let's look at main. Memory stuff. Open raw socket, which we'll look at just for fun. Parse options. I'm guessing these are command line options. Random. It's presumably a random generator, although it may not be as good as my random generator. Let's see. RTT, probably round trip time. Resolve is maybe DNS. Big numbers and big number tables. Something about scanning, script, send hcomp and send icomp. Well, ICMP, and I'm not sure about HCMP. Is this a real thing? The law offices. Guessing HCMP is maybe the hping's building on ICMP. You can send raw IP, send TCP. Let's look at send TCP. Look at send UDP. We've got signals, socket options, split, statistics. String L copy. I don't know what the L is doing there. Usage, version, and weight packet. Out of curiosity, I'll look at weight packet. I've got a few of them open. We'll just kind of plow through these, and that'll constitute like a first kind of walk around the grounds, and then we'll see if anything's worth digging into more. All right. Okay. All right. So in fixed types, we've got what? Some type defs. So I guess I forget how type defs work. I think the thing on the right is the new name. Let's verify that. Type def specifier. Used as specifies that a declaration is a type def declaration rather than a variable function declaration. Okay. So it should work like other declarations, which means the new name is on the right, is how I'm going to interpret that. Declares int to be an alias of type in. Yeah, okay. The new name goes on the right. So fixed types, for whatever reason, they prefer these types. If you're on Sun, I guess. Maybe for whatever reason, Sun has a different sizes than other things. Okay, and then here's interface.h, which seems to be network interfaces, like I was guessing. And we've got ioctls for M2 MII commands. Read from current phi, I guess physical, read any phi register, write any phi register, and read and set. I don't know what M2 is. I guess it's some kind of architecture. Basic mode control register. We've got whatever this stuff is. And we've got an hping if struct. So this is like their interface struct, and they've got loopback and address. I guess whether it's promiscuous, broadcast, no link. I guess you can set the MTU size or something along those lines. An index. And the index is only useful for Linux sock packet version. And PTP must be point to point, I guess. And we've got some addresses and some broadcast addresses. So that's what's up with the interface. And then this stuff, we've got things like ACK, remote fault, ability mask, flow control. I can find out what MII is. Media independent interface. MII connector on a Sun Ultra. Ethernet physical transceiver. Ethernet PHY is a component that operates at the physical layer of the OSI network model. It implements the physical layer portion of the Ethernet. Its purpose is to provide analog signal, physical access to the link. Just physical layer. Okay, cool. So something about this Sun connector is what I guess all this MII stuff is. I'm guessing it's probably out of date at this point. Here's main for hping. Copyright 1999. And how big are we? Not bad, 300 so. So what are we going to do? We are going to clear a bunch of stuff. We're just not even in a function yet, right? All right, so we've got a bunch of unsigned ints, some floats. Floats are things like round trip time statistics. And then the ints are things like socket packets, sock raw. I don't know if this is like an identifier for a packet or what makes it an int. I'm not sure, as opposed to some struct. Some options. Yeah. Okay. So a bunch of ops, and these are ints, but they're kind of really booleans. And then a bunch of cars, which are really strings. Things like data file name, target name, etc. Some unsigned cars, etc. Not so interesting. And here's main. We do something else, setting flags. Check for the scripting mode. So we might be doing scripting stuff, in which case we call hping script, and then exit. Unreached. Maybe hping script is supposed to leave on its own. Am I getting an error? Sorry, this hping binary was compiled without Tickle scripting support. All right, so if we're not doing scripting, I guess, then down here we parse some options. And it says hping2. I'm guessing that might just be outdated. Then down here, reverse sign. I guess opt sign in listen mode. We're doing some sort of reversal thing. And what else? Get the interface's name. We might be verbose. We might set some socket options like broadcast. Open sock packet or lib pcap socket. So I guess we must be there's some lib pcap stuff, I guess. I didn't see it in the imports, but I also didn't really look closely at the imports yet. And then we're going to get the physical header size. We might spoof the address. By setting it to spoof address. We're passing that to resolve, whatever resolve is doing. And then we've got this random generator, which we're passing the time to, I guess, as a way of probably seeding the random generator. And then we can do things like it's going to set the initial source port on what though? It's just going to record it, I guess. I don't think we're processing a packet, right? We're just taking 1024 and adding a random modulo 2000 to it. That'll be our port. What is it? What if that port is being used? I'm not sure. doesn't seem to be checking if that port is in use by something else. Okay. Use SIG alarm to send packets like ping do. Okay, so I guess SIG alarm is somehow used to send packets. I'm not sure how that works. Ask the ask Bard. Tell me how SIG alarm. How's it spelled? SIG ALRM can be used when sending packets. While it's thinking, I will. Oh, okay, it's done. Used when sending packets to ensure that packets are not lost or delayed. When a packet is sent, a timer is started. If the timer expires before a response is received, SIG alarm is raised. This can be used to resend the packet or to take other appropriate action. Okay, so SIG alarm is just doing what? It's starting a timer, and if the timer expires before response is received, we're going to get an alert, essentially. We're going to receive some sort of signal and use that to do things like decide whether to retry, I guess. Right? And then some binding stuff. What are we binding? Some stuff with print statistics. SIGINT and SIGTERM. I guess maybe if we receive the signal, we'll print statistics. Okay. And then we might be in scan mode. And this is just kind of one big main. We might be in flood mode. Send packet. So where do we configure? So if I understand correctly, part of the thing that's supposed to make hping cool is that you can craft special packets. And maybe that's in the options. These are all options. Like sequence number, trace route, and ICMP type. So I'm guessing these options account for a lot of the functionality. So let's see. An hping3 tutorial that's trying to tell us something cool about. How about DOS flood? All right. Okay, so we're gonna call S flood and V, maybe V is verbose to port 80 of whatever this IP address is. So let's look if we can see if we can find flood. Opt flood is false. Okay, good. That's probably a good default. And we just check if we're in flood mode just by this if statement in the main. So if we are in flood mode, we're going to print some stuff. hping in flood mode. No replies will be shown. And while one, we're just going to send packet. Okay, so we're just going to send packets on an infinite loop until until what? Until nothing. I guess until you kill it. And then what is send packet? Is send packet from the Linux kernel? What are we including? Some net stuff, ARPA, internet, signal, time, and PCAP. hping2.h. Possible that I'm in branch. I feel like there should be something more recent than 11 years ago. Utility no longer developed. They say that's the repo. Go to that website. While it's doing that, let's see what else we have. So we have open socket raw. And so this should just be like straightforward stuff. We're just going to call socket with the kind of argument enum define things that we've seen when we were looking at the Linux kernel. Yeah, this seems to be what Debian is using. Oh, does Debian have their own hping? Look at main. Was it opt flood? Let's look at opt flood. This seems to be mostly the same. I'm sure there are little differences. The last commit was 3 years ago. Well, 2 years ago. I guess this software is just perfect and it does not need updates. See the commit? Updated patch, spelling diff, updated D control, enable needs root. Yeah, this seems like it. It seems like these commits are maybe not uh, so fundamental. Okay, so I'm just going to believe that I'm looking at the right. All right, and we've got wait packet. Receive beep. This function is called for every matching packet received. If beep option was specified, the user will hear a beep for every received packet. This sounds like chaos, but it seems actually kind of useful. So we're going to print A, which I guess is the beep code. And wait packet is just going to do what? We're going to read a packet, get its size, and we're going to put the packet, I guess, in whatever packet is, our thing. If size is 0, we'll return. If size is -1, we'll exit. And then do some sanity checking for the header size. Or kind of like, is this a bad packet, etc. Check if the dest IP address is the one of our interface. The packet isn't an ICMP error. It should come from our target IP address. We accept packets from all the source if the random destination option is active. Okay, so we're just checking if this is our packet. And so if we match, we're going to increment receive packet and then dump it in hex, do some more printing, etc. Yeah. Okay, so this is all pretty straightforward. I'm not sure there's a whole lot to say here about hping3. Send UDP. What are we going to do? You're going to malloc some stuff. Check if it was null, in which case we'll error. And then set some header stuff, I guess. Sudo header size 0 on the packet. Mem copy some stuff into the, I guess we're setting like the sudo header. And you can add it to the delay table. And we'll send it. Send IP packet. What is the delay table? Sequence source port. I guess the delay table delaying something. But it doesn't seem to actually send the packet because we later call send packet, right? Able to be, not delayable, delay table. Hard. I'm guessing it's, okay. That stores the amount of time it takes for a signal to travel from one point to another. It is used in a variety of applications such as telecommunications, audio engineering, and video processing. Okay, so it doesn't delay anything. I thought it was, you know, a tactic to like queue something up or to delay before sending it out. But I guess we're really just recording um, like the time, the round trip time, or maybe just travel from one point to another, maybe just half the round trip time. Used to compensate for the different delays that signals experience as they travel through different parts of the network. This is important for ensuring that all signals arrive at their destination at the same time, which is necessary for things like voice and video calls. Like I said, it might actually delay it. In audio engineering, delay tables are used to create effects such as reverb and delay. Reverb's, reverb is created by sending a signal through the delay table, right? Very cool. So now I kind of want to look at the delay table, which I can do in Emacs. Let's see, in round trip time, here. So here's round trip time. And let's see, round trip time is going to look at delay table. So if we have some packet, presumably, whatever, I guess secp is some sequence number, a receive port, and ms delay are what we're passing into the RTT function. And we're iterating over the table size with this index I. And if delay table at I, if its sequence number is equal to the sequence that we're passing in, we're going to set table position to I and break. And then we might do some other stuff here. And if we're here and table position is not -1, which presumably it was when we set it, yeah. So if it's not the default anymore, so we've set it somehow through our logic, then we're going to set the status to the delay table status. And then delay table at the table position dot status is going to be set to receive as receive. And then whatever sec delay is, the time of null, maybe now, minus the delay table stuff. Similarly with microseconds. And if sec delay is 0 and microsecond delay is less than 0, we're going to increment the microsecond delay by whatever this is, 100,000 or a million. Then whatever the microsecond delay is, it's going to be the second delay times 1,000. I think we're just rescaling time probably to be the same unit. Min, average, max. I guess we're going to compute or print the min, average, max of the delay. And we're going to do some sanity check. Then we're going to return status. Who else is using extern volatile delay? In globals, delay table index, extern volatile structure. Where is it coming from, though? I don't think it's coming from main. It's coming from hping3. Delay table element. We have a sequence, a source, seconds and microseconds, and a status. Delay table element. Here's another delay table element thing. Okay. So somehow we're recording delay and we're using it to compensate for things. I don't know quite how, but the question of how doesn't seem to be in particular a thing about hping. I'm going to guess that ping has a delay table as well. But let me ask Bard. No, the ping utility does not use a delay table. It uses a timestamp to measure the round trip time, RTT, of a packet. The RTT is the time it takes for a packet to travel from the source to the destination and back. delay table could be used to improve the accuracy of the RTT measurement. However, the ping utility is not designed for high accuracy measurements. Okay. What about hping3? No. Yes, it does. All right. So it's doing some delay table stuff. Um, I'll look at a couple more files, but I think we have a sense of what's going on with hping3. So random is just going to be some random generator, right? And we've got our own S boxes. Got random init. Where you see the generator with user provided bytes. And HP generates a 32-bit random number using RC4-like algorithm. Yeah, they implement their own random number generator. I don't know why they wouldn't just read from urandom or whatever. And here's round trip time.c, which we actually already looked at because it's mostly delay table stuff. And here's send TCP. I think we looked at something like this, but basically we looked at like send UDP. I think we're just setting headers. Okay, so I think that's basically all that's really going on with hping3. Fixed types, gen tables. Yeah, so I'll leave it at that. So what did we learn? Well, it's nice to take a look at another utility that's working with sockets. We've looked now at a few networking things. Um, and when going into this source code reading stuff, I wasn't so familiar with networking. But now that we've seen a couple of these utilities that are staples of the networking toolkit, sort of the Swiss Army knives of networking and